Yeah, thanks for the introduction. I'm an engineer and a maker, so please forgive me the pragmatic design of my slides. I'll post them on my Twitter at Amberg later on, and they're all screenshots. Today I'll talk about the Open IoT certification mark, or short IoT mark. We're on Twitter as well with this project. It's IoT__mark, just in case it's not clear. IoT mark is a community effort for shaping better connected products. If you read about IoT today, it's mostly bad news. We thought it's time to define a more ethical approach and, above all, to give some good examples. That's what I try to do today. IoT Mark was initiated by Alexandra Deschamps-Sonsino and Usman Haq. They are both from IoT London. Alex is the organizer of the meetup group and probably the most connected person in IoT. IoT Mark was initiated by Alexandra Deschamps-Sonsino and Usman Haq. They are both from IoT London. Alex is the organizer of the meetup group and probably the most connected person in IoT. I organized the Zurich IoT meetup, and when I heard about IoT Mark, or its predecessor, in 2012, that was the Open IoT Assembly, I joined them in London to see what it's all about, and that's how I ended up becoming a contributor. The basic idea of IoT Mark is defining a trust mark for IoT, similar to the fair trade mark or label. It's like a sticker for connected products to help people make informed decisions when buying a product. Of course, IoT is more complex than a banana, so a more fine-grained approach might be required. As Peter Beer points out, finding a meaningful scheme turns out to be quite a challenge. The groundwork for IoT Mark was laid in June last year at the London Zoo. Over 60 people from the UK and all over Europe came together. We formed working groups and collaboratively edited a first draft in a terrible Google document session with too many editors. The current editing process that we have now that the event is over could be described as Jaromil's square of virtuous creations. By sharing and distributing our work under an open license, everybody can use and build it upon intermediate results. So it doesn't really matter if we end up with something, as long as we share what we do all along. To find a common language, we introduced a simple reference model based on this picture from the Eclipse Foundation. Devices are connected to the cloud. Services and apps use the data and control stuff. If you're a designer, you might ask, where is the human in this picture? And of course, there are other views as well. Here, the human would be on the probably application side for virtual interaction and on the device side for physical interaction with a sensor or actuator, talking to Alexa. A connected product includes the device, the backend, and the service it represents. We use device rather than thing or product to be more specific. The main result of IoT Mark so far is a number of about 30 principles, covering topics from privacy to product lifecycle. A detailed version of the principles is published on GitHub. The content is still quite rough and sometimes inconsistent. You're welcome to comment or propose changes on GitHub or on Slack. In March, we met in Berlin to clean up the first draft. We also tried to sort the principles into 3 groups. Here you see the must-have principles, We'll take a closer look in a minute. Besides must-have, there's a nice-to-have and a best-case category. This allows product companies to focus on the essential principles first and shows a way to the ideal connected product, if such a thing exists at all. Of course, priorities differ from users to manufacturers. Alex designed some nice cards with a principle each, so people can discuss and set their own priorities. Shortly after, we published the cards under Creative Commons. A slightly nicer version emerged from Albrecht Kurze, who's also a contributor. Okay, let's look at some principles. When it comes to privacy here in Europe, your product will have to comply with the new General Data Protection Regulation, GDPR. I think in 3 days or so it starts. What does that mean? It means the right to download all your personal data. You might have seen the link in Facebook. To migrate it to another service, the right to be forgotten, to limit how your data is used, and so on. Check Chris Adams' talk at the ThingsCon Salon in Berlin 2 days ago. I didn't have time to take a screenshot. Yeah, all those things are more or less common sense if you put humans in the center, but the big companies have to be told and watched. I just added the privacy policy to our IoT cloud service. That's what I do as a job. At the Ailer, we try to keep it simple and not gather personal data in the first place. So it's not so hard for us. Another important topic is interoperability. If APIs are documented, programming interfaces, devices can talk to other backends, or backends can talk to other devices. That's a bit technical. Here we see the API documentation for the U-connected lamp, or rather for the gateway of this lamp. I found it quite easy to build a custom adapter or a custom app for this lamp, given this documentation. So it could count as a good example. If a device API is public, you can do physical mashups. The OpenAPS project connects a blood sugar sensor with an insulin pump for diabetics. The glue code runs on the Edison, this small computer on the right, or a Raspberry Pi. The OpenAPS algorithm helps type 1 diabetics keep their values in check. Such closed-loop systems are not yet on the market, maybe in 5 years. But Dana here and the OpenAPS community are not waiting. As the medical industry is conservative, device APIs and communication protocols are not open. They are totally closed and sacred. This patient interest group therefore crowdfunds the reverse engineering or hacking of additional pump models. JDRF is a non-profit funding diabetes research, and they started lobbying for open protocols. Companies started taking note that previously unthinkable became the new normal. FDA, the US Government Food and Drug Administration, swallowed the pill and just authorized the first interoperable blood sugar sensor. They even promised a faster pass-through certification for open devices. This happened a few days ago, and it's really groundbreaking. And I'm very excited about open APIs. That's just to show why interoperability is important. They talk about open, but if we talk about openness, we mean open source, which is a step more than just documenting the APIs. Here, a great success story is the Things network. It's not really a connected product in the traditional sense, it's more of a middleware or a platform, but it has some nice lessons. It's open and free, it provides long-range radio connectivity, and their product includes sensor devices, a gateway, hardware, and a backend, which connects to custom apps of their customers. If you prefer to use your own sensor devices instead of theirs, just create an account to get your keys for the API. The same holds for gateways. The software is open source. Setting up your own is a matter of minutes. They also depend on people setting up their own gateways. It's a community network. The hardware designs, firmware, and even the backend source code is open source. This reduces dependencies to the project initiators, so big companies can use it and not care what happens to the project, which is a good thing. The Things network uses the liberal MIT license, which works even for enterprise customers. For documentation and physical designs, we, the IoT Mark, recommend using Creative Commons. Those licenses provide use and reuse, and you can also share, again, what you build on stuff you used from other people. Through their transparency and openness, the Things network attracted a huge global community in just 2 years, about 30,000 developers. And here you see the number of gateways. That's a measure for network coverage. It looks like starting to become exponential. Of course, open source does not equal financial success. My friend Jürg Lehny from Zurich, an artist, engineer, and creator of Paper.js, has to take other jobs to make a living. Safecast, the citizen sensing project, found a sustainable way to provide an open source connected product, including the hardware, which is open too. They are a foundation. During the Fukushima disaster, it's a classic example. Hackers started collecting their own radiation data. In the meantime, citizens, normal people, are covering the entire country and other parts of the world with connected sensor devices. The collected data is in the public domain. Even if individuals do not trust each other, the sheer amount of redundant measurements creates trust in the collected data. Of course, users should be able to get their data, not just personal data covered by GDPR. Connected products should also provide a way to switch them off, and they should not turn into bricks or something else once you bought them. Here, this is about the difference between personal data and data that's just collected in the places you visit. So maybe a humidity sensor knows that I took a shower, but somehow the data still is part of the bathroom rather than me. But it will be really hard to take this apart, and once it's in everything. So it's a huge challenge to stay fair and give you your data. Here, personal data from a fitness tracker led to loss of insurance payments, and the woman reportedly trained too much, so now she doesn't get support anymore, because she's obviously healthy. Sometimes there are unintended consequences. Strava published 700 million running traces around the world and other fitness data. This is Cologne. Everything was anonymized, as you should do it. The map is interactive, and a Twitter user interested in open source intelligence found out that the traces highlight secret army bases. If you're the only runner on an uninhabited island, anonymizing your data does not help. keep in control, switching off is sometimes the only option. Here, a user tries to find out if the Amazon Echo really cuts the connection when pressing the mute button. And there's no clear answer, of course. Connected products are other people's computers in your home. When Sonos decided to integrate their product with the Amazon Echo, this had catastrophic consequences for existing users that opted out of this feature because they just don't support, if you opt out, they don't support you anymore, you don't get updates. And not getting updates means your product dies. We also think it's important to keep a product's core functionality intact. Jared here might not be talking about connected products, maybe more apps or UIs, but his points still hold. Another aspect of interoperability and the consequence of the GDPR is the right to migrate your connected device to another backend provider. So this is a bit about ownership of the device. For example, the blood sugar sensors mentioned before connect to proprietary clouds. The Tidepool project tries to change this and liberate the data of the patients. They provide an alternative backend to store your data, but first you have to get it somehow out of the device. Current medical devices come with wireless remote controls like this one. Tidepool collects the same data in a better way. This looks a bit 90s or maybe even 80s. And it might be well designed for daily use, but this is the alternative. Once patient data was available through a well-designed API, engaged users teamed up with developers to build beautiful apps and nicely designed wearable interfaces. Interoperability and ownership fosters innovation. Device manufacturers also get free PR by providing a well-documented device and accessible protocols. Patients prefer to own their data. Connected products mean you depend on a service provider of some sort. Transparency becomes more important. If you buy a product, it's not your relationship with the manufacturer or the provider is not over, it starts. If an action creates unexpected cost, users should get notified. Just like the roaming SMS warning that you get when you step out of the plane and switch on your phone in a new country. Designers should take into account that users take their connected devices and products with them when they move. So that's also Alexandra's company, the Good Night Lamp. Who knows the Good Night Lamp? It's a connected lamp that has a big one and a little lamp, and if you switch it on, or if your father switches it on at his home, you see the other lamp lighting up, so you know he's switching on the lamp. It's a way to keep in touch without having to call. Sometimes there are no good options. When Kubachi was bought, the new owner decided to discontinue the connected plant sensor. This sensor told you when your plants need water. But Philip, the founder, it's also a company from Zurich, managed to at least provide a generous grace period for existing customers. So this 3-year sunset period is better than nothing. And he just had no more money to continue the service without support. He had to do all the work, so to say. It's not always obvious what is needed to keep a connected product running. Here's an attempt to reverse engineer the backend of Nabatstag. That's an early IoT bunny. Who knows Nabatstag? Okay, it's history. When the owner of Nabatstag went out of business, people tried to build alternative backends with various success. Most of them are just offline or gone. And yeah, there's no statistics how many bunnies are still connected in some way. A huge topic is, of course, also security. It's easy to say what's wrong. You read it every day. There's nice Twitter accounts publishing bad examples. But it's quite hard to provide actionable guidance without getting too technical. Here's a start. This blog post from a UK security firm does a great job stating what's wrong in a quite insightful way. They also have a great blog detailing possible attacks and showing you what can happen without just fear-mongering. We also found quite some best practice documents for different fields. This is more industry related, but the back end is probably the same as in a commercial product. Governments are also mounting the pressure. Existing actors like the IoT Security Foundation provide guidance to show how their advice maps to the new regulation. They figured it out long ago, but now they have to say, yeah, we are still relevant. Internet of Things Security Best Practices by Microsoft is also a nice document of high level but still useful advice, even if you're not a Microsoft person. And there have been attempts to design physically secure computers like this Orwell computer who deletes everything it has if somebody tampers with it. But of course, it's way too expensive to do this in everyday products. The last topic in our list is the product lifecycle. Let users know where it comes from and how to fix it. The premium example of sustainable design in electronics is probably the Fairphone. It got the highest repairability score on iFixit. That score is also an attempt to somehow help customers decide on this dimension if they should buy a product. The website helps people fix stuff, but mostly it's just nice to look at how your iPhone looks if you disassemble it. Safecast has another approach, a very simple one to provide repairability. They let users build their own product from standard modules. Once you build something, repairing it becomes trivial. And here's a great example of providing support during the lifetime of a product. During our work on IoT Mark, we found about 30 similar initiatives. The time definitely has come for ethics in IoT. It's no longer just Aral Balkan who talks about surveillance capitalism. Now it's the economist. And yeah, if you look at the third cover, the question might be if we end up with Silicon Valley style surveillance capitalism or a social credit system with Chinese characteristics. And maybe there's still some space between for a European perspective. We collected all this in our wiki. There's a lot of references and background information and similar or complementary efforts. We try to sort initiatives by focus areas. There's still some work to do. You're welcome to help us out. An early example from the ThingsCon family is the IoT Design Manifesto. I won't show it, but all my slides, the screenshots, are also links if you click on the address bar. So if you download the slides, you can read more. Another nice project is Better Things, which started as a diploma project of a design student. And my personal favorite is this Principles Documents by Consumers International. It's very consistent and it's focused on the user's best interest, which is the most important thing. What next? Alex and all of us will try to spread the word and get as much feedback as we can. And as it's a community-led effort, there is no fixed roadmap. We just see what happens and if people are interested. Personally, I'm interested in a lean approach that can be done without a huge organization like TÜV. I don't want to become a policeman policing products. I'm more interested in an automated assessment of compliance. Of course, you said before, Aline, that not everything can be decided with decision trees, and I would strongly agree, but some aspects maybe can. With some machine learning, we might be able to understand terms and conditions. Nobody reads them anyway, but... Another thing that can be tested automatically is the security of web APIs. This is our website tested by SSL Labs. They know everything about SSL certificates. You just enter the link and they say everything is fine. Because my partner is so good in doing this stuff. We didn't start with a name. And this is a picture from the DAOS project. It's a home gateway that increases transparency without collaboration from manufacturers. It just sits in your home and it shows you what's going on. And it tells you when you're close to call stop. Yeah, that was it. Consider joining the discussion. We're on Slack. You find it through iotmark.org. And my slides will be on Twitter @Amberg shortly. Thank you very much.